Good day everyone. So now we are going to discuss about how to use the Pearson R formula, when to use, and what is a Pearson R formula. So today we are tackling about what is Pearson product moment correlation coefficient. So the Pearson correlation coefficient is a descriptive statistic, meaning that it summarizes the characteristics of a dataset. Specifically, it describes the strength and direction of the linear relationship between two quantitative variables.
If the value is positive or negative 1, then the interpretation would be perfect relationship. If the value is positive or negative 0.70 to positive or negative 0.99, then the interpretation would be high relationship. If the value is positive or negative 0.40 to positive or negative 0.69, then the interpretation would be marked and substantial. If the value is positive or negative 0.20 to positive or negative 0.39, then the interpretation would be present but slight. If the value is 0 to positive or negative 19, then the interpretation would be negligible.
So we can see here a linear graph where it shows the value of the Pearson R, which is represented by a letter R.
In order to further understand what is Pearson R is all about, we are going to use it as an application to solve our problem. So, how to solve problems using Pearson R? So we have here the problems above that goes: the owner of a chain of fruit shake store would like to study the correlation or the relationship between atmospheric temperature and the sales during summer season. A random sample of 6 days is selected with the result given as follows, referring to the table below. So use alpha 0.05.
The first step is identifying the hypothesis. In stating the hypothesis, we have to look for the main objective of the statement that he is trying to prove. In this case, our hypothesis will be HO is R equals 0. There is no correlation between atmospheric temperature and total sales of fruit shake. Our HA is R is not equal to 0. There is a correlation between atmospheric temperature and total sales of fruit shake.
The next step would be identifying the level of significance that we are going to use in our computation. Since it was already stated in the statement, our level of significance would be 0.5.
Next to do would be identifying the degree of freedom and the value of our T critical, which is very important for our later discussion. The formula for degree of freedom is n minus 2, which is n is equal to 6 minus 2, meaning the degree of freedom that we are going to use is 4.
Next is to identify the T critical, which we will be basing in our table above. The intersection of our degree of freedom and our level of significance will be the value of our T critical. We can see here that our T critical is 2.776.
We are going to compute for the value of Pearson R. So, referring to the formula above, let me clarify it by explaining the symbols that was used in the formula. So, for the first one is we have the letter N, which is the total number of data. Next is the summation of X and Y, or the sum of the product of X and Y. And the summation of X, which represents the sum of all the values of X. Summation of Y, which represents sum of all the values of Y. Summation of X squared, which is the sum of all the values of X squared. And the summation of Y squared, which is the sum of all the values of Y squared.
In order for us to easily understand and make our data less confusing, it is okay to arrange our table like what you see above.
So the next thing that we are going to do is we have to substitute our value with a formula. So we have already determined our value for each symbol in the formula. Now we are just going to substitute it. So we have here in the upper slides, we have n is equal to 6. Summation of x and y is equal to 79,464. Summation of x is equal to 490. Summation of y is equal to 966. The summation of x squared is equal to 40,146, and the summation of y squared is equal to 158,352, which we can see here that was already inputted in our formula. And when we calculate it, the answer would be 0.95, which will be the value of our Pearson R, or represented as the letter R. The Pearson R is represented with the letter R.
The next slide would be determining the t value. Here is the formula for the t value, where R is equal to the value of Pearson R and n is equal to the total number of data. N is 6 and R is 0.95, which when computed using this formula, we can get an answer of 6.08, which will serve our t value.
So in using the Pearson R, here are some things to consider. As you can see in the upper table of consideration, we can see here that if the t value is less than the t critical, then the decision would be do not reject the HO, or the null hypothesis. And if t value is greater than the t critical, which is the decision would be reject the HO, or the null hypothesis. So going back during our computation, we got a 6.08 for the t value and a value of 2.776 for the t critical. So referring to the values above, we can clearly say that t value is greater than t critical, which means, referring again to the table of consideration in the previous slides, we can say that our decision would be rejecting the null hypothesis. The last thing and the most important thing to do is to state our conclusion. So our conclusion, or the final answer for our research, is there is a significant relationship between atmospheric temperature and total sales of fruit shakes. The strength of the correlation between atmospheric temperature and total sales of fruit shake is strong.